So do you know what we should do next?
Something with this.
Yeah. So I state that interface is already created. So now inside of our function, line 578, that's called a function.
Yeah.
Has the name of mutation names that remove tree. We're gonna create one of our global data store mutations. Remember, we have the secondary store, which we're in right now, store.ts, and we're gonna call a mutation a primary store.
Okay.
So, we are literally. Oh no! First, we need to find the parent ID.
Okay.
Because we're going to call a mutation on the parent tree to remove an element from
value,
the children property.
Yeah. Or the key, whatever.
Yeah. So, the way you find the parent tree is by first getting the tree data object for a current tree. So copy line 598.
This is finding the tree.
Yeah, and
should I paste it here?
Yeah, we'll delete the stuff beforehand. Like delete const mutation.
Sorry.
Yeah. And then delete the comment as well. The // that stands for comment.
Yeah.
All right. And then, so we're gonna make a variable. So old tree point, that's called a variable. It's a variable name. We're gonna create a variable called tree.
In place of this?
Yeah.
Capital T?
Lowercase. So you want to, except for when we're naming interfaces, you want to do something called camel case, where the first word in the word group is lowercase, then the second word is uppercase.
Okay.
So like old tree point. Old is lowercase, and the tree pointer uppercase.
Why is that?
It's just a convention.
Okay.
So tree, it's going to be available under our cache. Our cache is like a local representation of the database, and that's located under state.globalDataStoreData. So under global data store data, we have multiple object groups. One's called trees, one is called content, one is called tree locations. We're going to be accessing from trees.
Okay.
So change tree locations to trees. There we go. And now that this is really cool. So Visual Studio Code is smart. It knows that our cache expects a certain data type when we're accessing an element from trees, and that data type does not have the point element on it.
Okay.
Rather, trees have what three properties on them?
They have a
content ID,
property,
ID, and children.
Yeah. Okay.
Yeah. So, if we were to type .children right here, it wouldn't error out on us.
Okay, and that red line was obviously error.
But we aren't trying to get children. We're trying to get the entire object.
Yeah. Okay. So we just leave it like that.
So now make a new line and say const. Const just stands for like how you declare a new variable. Space parent ID with a capital I, is equal to tree.parent ID.
Tree parent ID?
Tree.parent ID. Yeah.
Now, one question. Spaces don't matter. It's just for neatness?
Spaces do matter in certain contexts.
Okay.
Well, I mean, like...
You don't have to go into detail.
Yeah. Actually, they rarely matter. Only one here. All right, so now we have a parent ID. So now we want to issue a mutation, a global data store mutation, on the parent tree. So we're going to copy line 601 through 608.
And what is this mutation that I'm copying? What is that from?
It's a mutation for moving the tree location by a certain delta. So we're in line 580.
See, I need to. Oh, now what is this? That's stuff that's not saved.
It is saved.
It's just recently.
It's stuff that's new since something called our last commit.
Okay.
So when you're done with your change, you're going to commit it to our Git repository.
Okay. Cool.
Yeah. All right. So yeah, hit enter and then paste. All right. So we're creating a mutation on what property of the parent tree?
There's three properties: children, food. What were the other two?
Parent ID and content ID.
So parent ID?
Well, we
No.
already have the parent tree now. We're
So we're doing
issuing a mutation on the children property
Okay.
of the parent tree.
Yes. And the numbers that were like 501, the numbers that were in the brackets yesterday, those are the children, or those are the keys of the children?
Those were the children.
Okay.
But what I drew on the whiteboard is not the actual database representation.
Yeah,
It was
okay.
a simplified version.
Yeah, okay, that's fine.
So we need to figure out what type of object children is represented as in our app.
Mm-hmm.
So the way to do that is go to the subscribable tree object. So Command P.
Subscribable.
Subscribable tree. Just hit enter. And then what type is children?
Mutable string set. Mutable subscribable string set.
Exactly. So go to files, the little that thing, and then go under objects. You probably have the components right now. Yeah, go under objects.
Where is it? I'm sorry. Okay, sorry.
Yeah. And then look for set. Yeah, and under set we have mutable subscribable string set. So click on that. And look under the add mutation method.
Mm-hmm.
So all of our mutations, they are of something called a generic type, which is a really abstract concept that I really don't expect you to understand.
Okay.
But our generic type is called iDated mutation. So command click on iDated mutation. And you'll see that it's an interface that says that any object that conforms to this interface by using like the colon interface name thing must have the property called timestamp.
Okay.
And that timestamp property must be of the type number. It must conform to the number interface. More specifically, the iDated mutation interface, it has a property called timestamp, which is a number, but it also, through something called inheritance, has all the properties defined in the iMutation interface.
Mm-hmm.
So command click on the iMutation interface. Yeah, chuck you right there. So the iMutation interface has two properties. One is called type and one is called data.
Mm-hmm.
Data, if you notice, it does not have a colon. What do you think that means?
That it's not a property of the interface?
So what it means is because data doesn't have a colon and then a type next to it, it means it can be any type.
Okay.
Whereas type, or actually let's go timestamp. Timestamp, it has a colon next to it, meaning it has to be of the type number.
Mm-hmm.
So types will throw an error if there's not a number.
Yeah.
Timestamp.
Okay.
So
data could be numbers or
strings or any other interface we declared here.
Yeah.
So line 415, if you catch on this quick, they'll be very that means you have a good brain. Type.
I didn't sleep that well.
All right, cool. So I don't expect you to forget. So type.
That's my excuse.
The colon next to it.
Yes.
It is of type mutation types. Mutation types is not any type.
Mm-hmm.
It's not an integer. It's not a string. It's like a variable that can be changed and have different values.
Yeah.
So mutation type is really, it's passed in as like an argument to our type. That's what the bracket mutation types bracket means. It means are you familiar with the concept of arguments and functions? Because we've been using them, but I never explained them to you.
Yeah. Well, you just explain them.
So
I mean,
let's say we have a function called square root.
Mm-hmm.
We can pass in an argument to the square root function, like 9. 9 is the thing we're passing in.
Yeah, okay.
The square root of 9 is
Yeah.
You can have functions with multivariables. So you can say
x plus y equals 2.
Quadratic formula function.
Yeah,
okay. Pass in a, b, c, and x equals obviously plus 1 square root of b squared minus 4. See if it's a, b, and c.
Yeah.
So you can pass in a, b, and c into that.
And those are all arguments.
Right.
Yeah.
So all of those functions, they return a value.
Yeah.
They take arguments. They return a value.
Yes.
Now,
you put the arguments into the function and it returns it out.
Right. What we've been doing is we've been typing the arguments of these functions.
Okay.
So we've been saying a in the quadratic formula case, we'd say a colon number, comma, b colon number, comma. C colon number.
Yep.
So we're saying
Yep.
types will throw an error if A is not a number. Well, now we're doing something like, so we call that typing. We are now creating types, but our types themselves can take arguments.
Yeah.
So now we're creating a type.
Well, it's just like A is equal to X, and then X can be equal to these different. Yeah.
Yeah. So
it's just like another level.
Yeah, it's like another level of abstractness. So
Yeah.
here we're creating a type called iMutation, and that type itself takes an argument.
Yeah.
Which says.
Yeah. Oh yeah.
Which says that this
no, I knew
property
I kind of knew that's what you meant.
Yeah.
Yeah, but thank you for explaining it more.
Yeah. So let's look at an example of a mutation type we can pass in to this interface.
Would it be like?
You won't. I don't know if you'll see anything.
How would it be like mutation type and then equals or something? How would I find it?
We'll show you. So yeah, go back to store.ts. Just Control Tab. It should go back there. Control Tab out. Not that.
Control tab. Thank you.
We
just go.
Refocus. Yeah. All right, just do that. Okay. All right. So here, the mutation we copied and pasted.
Yes.
It is of type iType ID prop data mutation. That's a really long type name. But that type itself takes an argument of point mutation types.
Yeah. Okay. So this is an argument.
That's a type.
Then this. Okay. This is a type.
Yeah.
And this is an argument that goes into that type. And the type is a function.
Type is not actually a function.
Okay.
Is it type? It's its own.
Okay. Okay.
So let's go back to interfaces.ts. What we saw was that we had iData mutation, right? That extended something called iMutation. iMutation says that we must have two properties in the object that conforms to the iMutation interface. What are those two properties?
I would say
they're type and data.
Yeah. Okay.
All right. So the iData mutation interface, it's saying by extension that we must have three properties in the object that conforms.
Because this has one and this has two.
Yeah. So what are the three properties?
So we have data, type, and then timestamp.
Exactly.
Yeah.
And then data must have the type of what?
Mutation. Wait, no. It could be anything.
Yeah, it could be anything. Timestamp must have the type of
number, and then type must be
of the
now.
type.
But this is going to change. This can change.
Right. Type will have the type of whatever we pass in the brackets here. Mutation type. So if we go back to store.ts.
Wait, say that again. Sorry.
Type will have the type of mutation types.
Yeah.
Sorry, no. Yeah. Mutation types. So mutation types gets defined when we label our object with the interface.
Okay.
So yeah, go back to store.ts.
And we label it with
mutation types is point mutation types. That's what we're passing in. That's the argument we're passing into
mutation types.
Yeah. So command click on a point mutation types.
Okay. So basically, if I put point in front of it, it's a type of. Point is a mutation type, or no?
Well, point mutation types is just an interface.
Okay.
It's any old interface. It's just a type. That type could be defined to be anything. It could be defined to be an object that has to take 100 variables.
Okay.
It could be defined as an object that takes 2 variables.
Yeah. Okay.
2 properties. Here, if you command click on it, you can see what it's defined to be. So it's a type of object called an enum. And that enum has 2 values in it, either shift or set. So essentially what we're saying is that we go back to store, go back to store, and then command click on iType ID prop data mutation. What we're saying is that we're saying that mutation types, in this case, where we're saying that type can have one of 2 values. It can have
shift or set.
Yes.
Yeah.
And if it doesn't have any one of those 2 things, types will throw an error.
Okay. How do I let me take me from here to where I see shift and set? I just hit this. Or
It's
no?
not going to, no, because that,
How do we get there?
go to store TS,
Okay.
store TS,
Store TS.
and then command click on
This
point
one?
mutation types. Point mutation types.
Okay. Nice.
All right.
Now, is there only one? See, because you have point mutation types and you have field mutation types.
Yes.
So how does it know which one to talk to, which one to, you know what I'm saying? Or no?
Yeah, so we have to define that in the mutation we're creating.
Okay.
So we're in our case, we're modifying a set. Remember the children properties and mutable subtractable set?
Yeah.
So we're going to use set mutation types,
Okay.
which just happens to be, go back to interfaces. It happens to be defined on line 472.
Okay.
So we can do two things with a set. We can add an element to it, or we can remove elements of it.
Mm-hmm. Okay, so were you just talking about point mutation for just as an example?
Yeah.
Okay, cool. Yeah, okay.
All right.
So we're going to put this.
So yeah, so we don't need to copy the whole interface.
Okay.
We're just going to, I'll show you how to type it in. So go to store TS. So our mutation that we're creating, it's going, the type property in the mutation. Remember how the mutation has like 6 different properties, and one of them is called data, one of them is called timestamp, one of them is called type.
Mm-hmm.
The type of the type property is going to be set mutation types.
Okay.
So change point mutation type to set mutation types.
I see.
So now, hover over type, and TypeScript is now complaining.
It knows. That's dope.
So no, the type is fine.
Oh, it is? Okay, okay.
We just need to now give it the specific value in the set mutation types interface.
Where's the set mutations type interface?
Yes, so command click on that.
This? Okay. So when I click this, this is the set mutation types interface.
Yes, and
Okay.
it has two. So that interface defines that any element conforming to that interface has to either be called setMutationTypes.add or called setMutationTypes.remove.
Mm-hmm.
And any other value does not conform to that interface.
Mm-hmm.
And it's a special type of interface called enum.
Mm-hmm. So
go back to store, and if instead of typing point mutation types.set, you're to type line 585, you're to type set mutation types.add or remove, the red underline will go away.
Okay. Okay. Yeah, I just have to change it to set right here.
Yeah. But set is not an available property.
It have to be add or remove?
Yeah, it'll auto-complete.
Oh, nice. We want to remove.
Yeah. All right, I threw so much at you. Which parts do you not understand?
No, I think let's just keep going because I want to watch these. I'll watch these, and I can pick up on like what I don't know. I'll Google terms, and then I'll come back to you with questions because I don't have questions right now. I'm just kind of like I'm just like kind of taking. I'm your like just a little robot, but I'm kind of getting it. I can't wait till it all clicks. I just can't wait till it clicks.
So the object type, what do you think we should be putting there?
Parent ID.
So the object is the tree. The property is so okay. We're modifying the parent tree.
The parent tree.
Yeah. So
yes.
It's a type. It's object.
So that's what tree. That was the answer was parent tree.
Nah, the type is just tree. Because the parent tree and a child tree and a grandchild tree, they're all the same type, and that type is tree.
Okay.
So.
Okay. Oh, it's just like, what is the object? It's a tree.
Yeah.
What are the other options?
Yeah, so
are there like millions of other options
there's
for object types?
Backspace.
This is object-oriented coding.
Yes. This is slightly. We have some custom things that's
cool.
A bit additional. So backspace tree location. And the backspace all the way. Backspace dot. Oh yeah. So now type dot.
Dot.
Okay. Well, it's actually going to be type. So type s dot.
Types.
S dot. So those are all the types we have available
in
our global data store.
Mm-hmm.
Yeah. So we have our secondary store, which is store.ts.
Mm-hmm.
We have a primary store, which is global data store.
Mm-hmm.
And that global data store contains five lists of objects.
Mm-hmm.
One is a list of tree objects, one's a list of tree locations, et cetera, et cetera.
Mm-hmm.
We created, you're going to,
Sorry, I was just trying to bring.
Yeah, if you want to bring the whole list, you got to backspace the period.
Yeah, okay.
We created an object called global data store data types, which lists the available types.
Mm-hmm. Yeah.
Now, if you want to learn something new, command click on global data store object types. I bet you anything's going to,
Yeah.
So you might kind of be getting an intuitive sense of what an enum is. It's like an interface that specifies a list of available values an object can have if it wants to conform to that interface.
Yeah. It's like the criteria, right?
Yeah. So at any object or variable that has the colon global data store object types, it must be one of these values.
One of the 5.
Yeah.
Now, this is just linking things together. It's not. Are any of these actually like executed things?
No, they're just.
This is just
they're name tags.
Linking it, everything.
Yeah, they're literally just names. Just something called strings. So that we can make sure we don't make typos in our code, and to make sure TypeScript will yell at us if we accidentally type like tree with 3 E's.
Yeah. Okay.
More specifically, it'll prevent us from saying global object store types.
And doing something that doesn't exist.
Elephant. Like there's no elephant type.
Yeah.
All right, so we'll go to store.ts.
See if it works.
There we go.
Nice.
All right, so we have the object type correct. Now the ID of the object that we want to mutate, it's not tree ID. It's we want to mutate what? Which object?
The children.
We want to modify the parent object.
Okay.
We want to modify the children property of the parent object.
Yes. Okay.
So our global data store is going to parse your message, parse your mutation, and look for the object with the given ID you pass.
What is parse?
Read.
Okay.
Yeah. So you want to, good question. You want to do ID colon parent ID.
Okay. Yeah. Okay. Now the parent is basically within the tree ID, right? It's tree ID, and then within that is parent ID, or no?
Oh, that's a good question. No.
Okay.
Yes, but not in this context.
Okay. You don't have to explain if it's too.
Yeah. Each tree has 3 properties, right?
Yeah.
Each tree itself is also given by an ID, right?
Mm-hmm.
So the way our program looks up the trees is by their ID.
Mm-hmm.
So let's say we've looked up a tree by some ID we have like 1, 2, 3.
Yeah.
Now we have the tree object, and we can look at that tree object, get the parent ID.
Uh-huh.
Now we can use that parent ID to go look up the parent tree.
Yeah.
So here we obtained the parent ID, and we're using our mutation system to look up the tree with that ID.
Yeah.
Parent ID.
So this is basically just it's a variable array.
Yeah.
Yeah.
Timestamp, that's fine. We can use date.
We're going the other way. We're not coming from tree ID down. We're kind of using this to find the tree.
Yeah.
Yeah.
And then mutate it.
Okay, wait.
Okay. So type is correct.
Okay.
But the property that we're modifying, it's not point. Point only exists on tree location.
Yeah, it's going to be set or shift, right?
No. It's the property we're modifying is called children.
Yeah. Okay.
But children is not going to be named under tree location property names. It's going to be under tree property names.
Where's that?
So yeah, command click on tree location.
Oh, okay. Should I make this back?
Yeah. Command click on tree location property names. See how All right. So again, this is another enum. It's like a list of possible property names for trees.
Yeah, and
enum
is just keeping everything crispy.
Yeah. So tree locations, they have a point. Point itself is a XY object. Like an XY coordinate there. Map ID. There's like everything map. There's RJ's map. There's John's map, and then level is something else. We want to find somewhere else. I created an enum called tree property names. So Command F for Command F.
Is it different?
Command F searches in a file.
Okay. And P is through the whole program?
Yeah.
Okay.
So, Command P searches for file names. Command F searches for
in the code
strings within the file you've opened. So search for tree property names. It's one word. I'm not sure if it's space sensitive. Yeah.
Sorry.
Property
names.
Right. So there you go. There's us passing it in as an argument into another type. But command click on it, we can look at the definition. Command click again. There we go. So we have 3 available property names, as you already know. The one we're modifying is children. So go to store TS, and instead of saying tree location property names at point, we're going to do tree property names dot children.
Okay. I'm just gonna ask myself this question before I watch it.
Yeah.
I'm gonna what was the difference between what was just there and tree property names? It was tree property.
It was tree location.
Tree location
dot point.
Dot point. Yeah. So I'm gonna try to figure out what the difference between tree property names and tree location property names is.
Right. Now you might. So command click on tree property names again. If you look closely, tree property names dot children is set equal to the string called children. A string is just a piece of text denoted by quotation marks.
Yeah.
So equivalently, we could literally just type uppercase children over there, and it should work fine.
Okay. Here. What?
Yeah.
Just like in place of that.
Yeah, I don't think it should error out. Well,
okay.
Yeah. We could literally.
You want to try?
Yeah. It won't error out. I know it won't. It's how we set up. So it needs to be quotes. So it needs to be a string.
Oh, okay. Basically the same thing. I see. You just set it equal to children, so that.
No, actually,
what?
It does error out on that, which is cool.
It's cool. It's like a good thing.
Let's look at the underline. What's it say?
Should I not click?
Don't click. Just on the mouse.
I'll click.
There. Okay. Yeah. So that's a good thing. Functionally, what the program does, what the code does, is it just looks at the string name and then finds the property based on the string name. But
it goes back to where it equals, and then it figures out what it is. Yeah.
Yes, but the way we have our type system set up for mutations is that we want to restrict the property names to valid property names. Like we don't want some type elephant. There's no elephant property exists on any of our objects. So the type system.
It's checking to see if it's actually
a valid property.
Yeah, yeah. Okay.
And the way we do that is by using those enums.
Yeah, very cool.
All right, and then data.
Is that like a clean code practice?
Yeah, it just prevents typos. You can spend 4 hours trying to fix the typo and have no idea.
Yeah.
But if you spend an extra 5 minutes writing types,
yeah.
it takes 4 hours.
That's what typefaces are, basically? Or typesets? What is this?
This is called TypeScript.
TypeScript. And that is basically whatever you type, it's checking to see if it's legit.
Yes.
Okay.
All right, so the data we want to pass into this mutation to figure out format of the data. Well, okay, to delete just delete all of this, and then we want to remove tree ID from the children's set of the parent tree. So type in tree ID inside of data. And that's all you need. And we're going to explain how that works now. So go to subscribable tree, or mutable subscribable tree.
Is it there, or is it?
Yeah, hit on it. All right, scroll down. Oh, yeah, so let's look at add mutation. So eventually, our global data source system looks at mutation, finds the right tree, and then calls add mutation on that tree. And then this function right here called add mutation, it looks at the property name, and look here, it only has logic written for 3 possible property names: content ID, parent ID, and children. If we had something else, it would throw an error. So it adds a mutation on children. Children is defined in, children is of type mutable subscribable string set, as you might remember before. So actually, let's go to that file. Hit Command P, mutable subscribable string set.
Oh, shoot.
You can just type MSSS. There we go. Get that out. All right.
Is that why we do caps, so that we could search it easier?
Exactly, yeah. So the add mutation method on here, we just called that from mutable subscribable tree, right? What this does is it will call one of our 2 internally defined functions. It'll call this.add, or it will call this.remove. And the argument it passes in is literally just the value of mutation.data. So see how in add we have an argument called member. Member is of type string. And then remove, we have an argument called member. Member is also type string. Member, go to store TS. Member is tree ID.
Okay. So do I do colon tree?
No, we're good.
Wait. And say that again. Member.
Tree ID will get member will get the value of tree ID.
Okay.
Eventually.
Yeah. Okay.
So we had a function in one file over here where let's say tree ID was set equal to 125, right? We called the mutation, it went through a global data store, found the right object type collection, found the right object, found the right property, and then it essentially, this whole chain of logic passed in the value of 123 into our remove function.
Yeah.
But now, we don't type a 123 in our remove function. All we have to do is type member, and member will have the value of 123.
Yeah, it'll
because that's how variables work.
Yeah.
Take any value.
Yeah.
So yeah, this function, it does stuff. It deletes the value from the set. It publishes updates through some mechanism, and then our database and another mechanism receives those updates.
Oh yeah.
So let's go to store TS. Alright, save what you have while you're at it. Alright, so we've created this message. You can think of it as like a note that gets passed on to another part of the system, but we haven't passed it on to the other part of the system. And the way you do that is, let's go down to 609. Alright, the way we do that is by calling state.globalDataStore.addMutation, and then you pass in the mutation you just created into that mutation function. So you can copy that line, go up to 588, and paste it after 588. All right, and let's scroll down. Let's see if I did anything else in this function. That's all we have to do. So we created a mutation. We call the mutation, and this should literally delete the tree, remove the tree.
The whole tree, or just that one?
It's going to, it's going to remove the tree from its parent. Meaning the tree object will still exist in the database, but next time we load the parent and we look at the children of the parent, it won't exist in that children. So we aren't going to end up loading that. The way our system works when we load is first we load the everything node. We look at all its children. Then we load all the children nodes. And then we bounce over that child. We look at the children property of that child.
Yeah. And it would just, wherever you hit delete, it's tree, so that the whole tree after is removed.
So what I don't know is if, save this. What I'm not, we might have a bug in our code, so it might not work.
Okay.
But what I'm also not sure about is if when we click delete, if it will change it in real time, or if we have to refresh the page. So we'll figure that out. Let's go to localhost://edu. And definitely don't do this on the everything node. do it on some leaf node that we don't care about. Or maybe just do.
Oh my God! Are you able to do it so that they don't delete
Yeah,
that?
yeah, yeah. We'll change that.
Okay.
We won't publish it until we get it. Let's just modify stuff under RJ's.
Yeah. Okay. Yeah. We'll do this.
We can create something.
No, this. I didn't use this.
All right. Okay. So command option J.
What's this do?
It opens up the developer console.
Okay.
All right. So remove. All right. It keeps printing out remove. Right. That might be because our method actually never calls the mutation. You just have to print out remove. So go to tree.ts under the components folder. Yeah, this is it.
Okay.
Let's look at the remove method. Yeah. So
where, right here?
Yeah. So we need to call the mutation we created in store TS. And the way you do that.
Do we just paste what we had? Or no?
No, not that. You want to type me.store .commit mutation names.
Capital?
Actually, yeah, just follow this format right here.
Okay.
Yeah, copy all of that. Parentheses for 173.
Yeah. Okay. So, just like this?
Yeah. Okay. And so that's the mutation name of our secondary store. So let's go to store TS. See what we call the mutation. We call it remove tree. It's mutation names that remove tree. So go to tree.ts. Type mutation names that remove tree. Yeah. And that is our hard cutoff. I gotta have.
That's fine. Mutation underscore tree?
It's remove tree.
Okay.
Now, ideally, what I'd love to do is we create these videos.
Yeah.
And then we create a system of branches where when you play a video, it has the pencil map next to it. And every time you're in a new section of the video, it jumps to that part of the pencil map.
Yeah. And the pencil map is what? The what you see?
Yeah. And if you were to click onto that part of the map, it would jump to that part of the video where you learned that topic.
That would be fucking sick. Yeah. I love that. Dude, there's so many cool things to add. Like, do you know how? Would you know how to do that, or do you figure it out?
Oh no, we don't know how to do it. We'll figure it out.
Yeah, like, did you just kind of like make this more and more complicated as it went, or did you have did you know all this? But like obviously, I mean, you used search and stuff, but I mean, like, where did you learn all this in school, or did you learn this on your own? Like, they don't teach React Native in school, do they?
This is Vue.js. It's on.
This is okay.
Vue.js and TypeScript they don't teach in school.
Okay.
I first created a prototype in JavaScript, and my code had so many bugs, so many issues that it got to a point where every time I'd add one thing, 3 things would break.
Yeah.
Like FS, I had to learn how to code properly. So I read about clean code practices. I learned about something called TypeScript. I learned about something called mutations. And I ended up designing the system based on that. Yeah. And then I found that the other systems already exist that kind of incorporate those principles.
Okay. Oh yeah. And what made you do? What is it again?
TypeScript.
TypeScript, Java. What's the name of the language that this is in?
TypeScript.
Is it several different languages?
So TypeScript is something called a superset of JavaScript. Okay. Meaning anything that's valid JavaScript is also valid TypeScript. But you can type regular JavaScript, and then each variable you can do that colon type name. Yeah. And it'll throw an error if that variable, if you assign a value to that variable that does not conform to that type. Yeah. Okay. Very cool. And you chose this because obviously you can run this on, on web and stuff like that, you know. Yeah. So TypeScript compiles to JavaScript, and JavaScript runs in browsers. Yeah. PHP doesn't run in browsers. C doesn't run in browsers. Only JavaScript does. Yeah. Oh yeah. Yeah. All right, bro. Nice work, man. Text me if you have any questions on the code, and then we can or make a list. We can go over that tonight. Yeah. I have class at 11:15.
after that, I will spend half of my time doing customer stuff and half of my time working on this. And then I have the 500 Ferns thing. I'm going to go there at 6:30. He has to use my computer.
Yeah.
And then I'm going to probably go to dinner with my mom.
Gotcha.
So
do we want to meet up this afternoon?
We can if you want.
It would have to be before 5:30?
It would have to be before 6:30.
Before 6:30.
So we can meet up at 5:30. Or
yeah, it will be 5:30.
Whenever.
We'll do a hard cut for about 6:15.
Okay.
I mean, if you got to get to Carlos in early.
It's for the Independence. So we can do 6:25.
Okay. Yeah.
Or well, how about 5:15 and 6:15?
Yeah, 5:15.
Hard cut off.
Yeah.
And we'll meet here. Or do you want to
Yeah,
meet
this
at
room
Smith?
might be taken. I'll try to get the Smith room.
Alright. Yeah. Well, somewhere around here, one of us, you go to Smith, I'll come here, and whoever gets a room, we'll text.
Hopefully I'll be working in 7 hours beforehand.
Yeah, okay.
Okay.
Okay. Alright.
Alright, awesome.
Alright, cool, bro. Peace.